in this problem, we're given n buckets. We can think of our buckets as these balls here, and we have n of them. And we have k items. The idea is that for each item, we're assigning one of these buckets. And we want to know what's the probability that what's the probability that there is a bucket with at least 2 items in it. So as an example, let's think of k being 3. So we could have one assignment could be this. We could have an item here and then 2 items here. So notice that this bucket has more than one item. So these are the events that we're interested in. So this problem is in disguise the same as the birthday problem from the lecture and the reading. And the way to think about this problem is for each item, we sample one of these buckets. We have n of them, so we sample one of them, and we're sampling with replacement because each item has n choices for a bucket, where each of these buckets is equally likely to be picked. And this is exactly the scenario, the setting of the birthday problem. So if we let A be the event that at least one bucket has more than one item, then we can compute the probability of A by computing 1 minus the probability of A complement, where the A complement event is exactly the setting of the birthday problem. In other words, each item is assigned a unique bucket. And so by the birthday problem, we know how to compute this probability. So the first item has n choices for a bucket. The second item has now n minus 1 choices, not n choices, because the first item was already assigned a bucket. Now the third item has n minus 2 choices for a bucket, and the kth item has n minus k plus 1 choices for a bucket over all the number of possible selections, of k buckets. So this here is our answer.